Alright, so let's get started with one of the most common and popular types of weld, the good old-fashioned fillet weld. Now, a fillet weld by definition will have to have a cross-sectional shape that is, very similar to a triangle. Obviously, it's not a perfect triangle, but it's close to it. And you're going to recognize some of the other terminology that we associate with the groove weld. For example, the toe, what the base metal is, where the weld face is, the weld metal, in the interface zone, that sort of thing. Now, by default, we're almost always going to assume that if a fillet weld is specified, that we're dealing with a 90-degree intersection. In the event that for some reason this was not a perfect 90 degrees, and let's say it's like 75, that type of weld process would have to be very, very specific, because the fillet weld is based on a lot of premises, and that typically means that it is 90 degrees for calculation purposes. Now, this particular example of a fillet weld is a single fillet weld. For example, we have this nice T-joint connection, but we only have a weld occurring on this side. If it were on this side, then we would actually have a double fillet weld, which obviously is much stronger than a single fillet weld. You're going to see fillet welds time and time again. I mean, it's one of the most common welds, especially in large-scale structural fabrication. And it's usually one of the most popular because it's a straightforward, easy to calculate, and easy to perform type weld. And they're good for transferring loads. It's just a great way to transfer a load from horizontal to vertical and vice versa, and a variety of different shapes. So we'll get into the overall call out for this, but there's your typical fillet weld. Now let's talk about another type of common weld that you see a lot in structural fabrication. When I say structure, I'm talking about building structure. And that's the plug or slot weld. Now, a good example of where this is performed, you'll notice that it's a lapping situation here, a lap joint. But if you think of metal decks that are often put on building roofs, or even the floor system before concrete is poured into commercial buildings, there is metal sheets that are laid on top of metal joists. Now, these are bar joists or W-beams, that kind of thing. And these sheets are laid down, but how do you connect the sheets to the metal below, the metal joists? What they'll do is they'll basically do plug welds, where they'll go along every so often and penetrate to create a weld component between the joist below, and here I'll just draw the joist out there, there you go, the joist below and the metal sheet above. And they'll actually do it on certain pitch, size and pitches, and we'll talk about what that is a bit later on. But there's your concept. We're going to penetrate the top layer of material, the top base metal, until we make contact with the lower base metal. So, part A to part B, we're going to burn through part A until we get to part B. Now, don't get me wrong, sometimes this can be facilitated by pre-done holes that make it a lot easier, but it's not always the case that those holes are going to be provided. Sometimes burn through is how they'll actually make the connection. And there's, of course, differences between a plug and slot weld. Obviously, a slot weld is when you're getting a cross-sectional shape that is longer, more drawn out. Obviously, the slot welds are also stronger because we have more connection. Now, a plug weld will typically be circular. Slot weld will be elongated circles. Makes sense. And obviously, your fusion of your base metal and your filler metal is occurring in these zones around the edges of, we'll call it part A, and also at the surface, the top surface of part B below. So this is where we're getting a lot of mixing of our metals and a lot of our strength and binding effect. This type of weld is always good with shear forces. For example, on buildings in this type, we have a lot of loads that are applied to the system through the sheet system. This transfers a lot of that energy to the joist members and the framing members this way. So it's very, very common with sheeting and layering type applications. Now, another type of weld that you don't see necessarily as often is a stud weld. Now, this is more of a mechanical process for specific applications. It can be used for creating actual components. One of the key things you understand, though, is at the end of the day when this process is done, it's not like you're taking a T-joint and welding a fillet weld on the sides. You're actually putting a part, let's just say some kind of cylinder, and attaching it to some kind of other material via itself. So for example, the stud weld actually arcs itself into place, as you can see in this process. Studs are actually welded to other parts in fabrication. This is not usually a field or repair work. I guess it could be repair, but this is actually a manufacturing process that we use for a lot of different applications. So for example, we want to have reinforcement placed into certain levels of types of concrete and that kind of thing, or maybe angles attached to it. We will add studs to them, which can be done in a variety of different ways. It can be done with just like metal cylinders and fillet welds, but this also allows it to basically be a part that sticks off after the impact. So if you watch the process, you basically bring the stud in and you pull it off to create the arc. The molten metal is then created at that moment. You plunge the stud back in and you complete the process, and now you have a part that is typically cylindrical and attached to another part welded unto itself. Notice that you didn't have the ability to get in there and weld it with fillets or anything of that nature. You basically used its own process. So that's a little stud weld. You don't see that nearly as often, and obviously it's a very mechanical process that can be done by machines pretty effectively. Now, just for a little bit of terminology's sake, the following weld types are ones that are likely not to run across for your manual operations. These are more mechanical or machine-based systems, as you can understand through the process of how they're done. Now, the terms you might have heard in different ways, but I doubt that they're referring to the same thing. So, for example, when someone's told you to do a spot weld, this is not what they're actually talking about. Now, this process involves obviously a lot of heat and pressure. That's why I say it's more mechanical. But a spot weld can be done by creating a fusion event or weld interface by not actually preparing the surface, but just applying the actual heat and pressure in a circular shape. You can see, they even use the term weld nugget. You can see the kind of demonstration there. Spot welds, again, these are mechanical based, and they're actually an internal weld type of situation. But if you did enough spot welds, you actually can get a seam weld, or you get, an overall creation. Again, not something you're likely to see on a set of plans called out because it's more a mechanical process. But you can see overall in the cross sections here kind of how it's done. We got a projection of applied to the shape before, pressure's applied, you get the weld nugget effect, and you probably get a little bit different in terms of projection welds. Now these of course are based on electrical current, resistance to flow, all that good stuff that actually can create the heat that we need. But you can see a little bit difference in terms of projection welding and over the process. The spot welding and projection obviously require, specific equipment just for those processes. Like I said, that's why you're going to see it more as a process plan than it is going to be just typical shop drawings with weld symbols that you'll run across. Now, another little piece of terminology, the term a back weld versus a backing weld, again associated with a groove weld, but essentially you're going to be working at the root, and this is the process of actually setting it up for a groove weld or finishing a groove weld. So a back weld is made after the groove weld occurs. So you come and do your groove weld, and then you flip it over and you weld a bead along the root. The backing weld is one that is made before the groove weld. So you actually take your butt joint, flip it over, run your bead across the joint. It's a small penetration, as you can see, at the root point, or what's going to be the root once you do your groove weld, and flip it back over and do your actual groove weld at that point. These are reinforcement welds essentially. Sometimes they're also a finishing type of component. They obviously create some added strength when made after, but they can also be a great tool for binding it to prepare for the groove weld when done before. So another little piece of quick terminology there. Now another specialty weld type is the surface weld. When would you might actually do a surface weld? Well, that would probably be on some repair jobs or some jobs where you're actually trying to protect a surface from wear. Could be an abrasive environment, and you're essentially building up material on top of the base metal. So you're taking something that you have and you're technically either repairing it. For example, maybe it got wore down through elements and stuff, and you're going to build a layer of material back on top of it, or you're going to use this layer of protection, which is going to make it thicker over time or over the process, to actually protect it from some type of situation. Who knows? This is obviously very abrasive resistant, so if you wanted your part to be well protected, you might do a surface weld. One other interesting feature about surface welds is they don't necessarily have to be the same characteristics of the base metal. So the filler material that's coming on top could slightly be different for one reason or the other. It could have some special properties that you want it to be, since it's going to be a protection application many times. Your filler material could be something very different than the base, just for that protection process, which is what sets it apart from most welding processes. And you could keep coming back, so you can do layer after layer to continuously build up. Obviously, this would take a long time if it's a large, a lot of surface area, but you'll see this in repair work, especially just because of the fact that parts get worn out, and this can actually add strength back in. One of the interesting things also about the surface weld process is you can actually sort of layer it conversely. So if you are going to do that layering component, then you're going to go one direction, then you're going to go another direction, using 90 degrees to that to create almost like a fabric strength associated with that particular layer. Okay, so that brings us to a good stopping point with the surfacing weld. We'll pick it up on the next one. See ya.